Yeah, here's an example. So treasure hunt example. So the player is given the first chit. This is the first chit. So it's written Sam's study table. So the player goes to Sam's study table and he finds a chit in the drawer, and the chit says Alex's room door. So he goes to Alex's house, and he checks out for Alex's room and the door, and he finds a chit in the doorknob. And this chit says Karthik's bed. So the player goes to Karthik's house, finds Karthik's room, and then checks out his bed and finds a chit below his pillow, and that says Kiran's math book. He goes to Kiran's house, his room, study table, math book, finds a chit in his book, and so on. It goes, actually speaking. And at the end of the game, you find some treasure. You say maybe this math book has some coupon, some some coupon, some movie ticket or something. So that's the treasure, something like that. And same way, linked list concept goes on. It's like, as I said, a node has a link to another node, and that's why each node has a data field and a link field, address field, as I said before, but hereafter I'll say link field, and I'll explain later about the address field thing. I mean, both are the same though. So yes, say the same treasure hunt, I can have it as I can modify it. So I'll give I'll give the player the first chit as a normal chit, and the other chits will be in a box, and each chit will be in a box with some object. So let's say the first chit is just I'm going to give the player just a single chit without any box or anything. So yes, I'll give him this chit, and it says Sam's study table. And now he goes to Sam's study table and he finds a box. This box has two things, an object and another chit. So this object is the information, as in linked list. So there are two fields. The object is the information field and the chit is the link field. So say Sam's study table, the box, it contains maybe some toy and the next clue. So the player takes the toy and he takes the next clue. The next clue is Alex's room door, and maybe in front of Alex's room door there's another box, and it has another toy or maybe some key or something, some object, and with another clue, and so on. So a node can be explained that way using this example. And actually speaking, this is a specific linked list. Again, I'll explain those later. Just for the basic thing, I'm explaining this. Yeah. So how do I implement linked list in C programming? So there are some things to be told and explained. I'll tell one by one. You must listen carefully. So the first thing I'm going to tell is how do you implement them. Since I said a node has two fields, a data field and a link field, I'm going to have to use and node is a single unit. So how can I implement it? I have two fields, in the sense the data field, the information, it need not be a single value, it can be more than a single value. Say I have students' mark sheets and all in a class. So each node will contain the marks of a student and a link to another student's information, something like that. Another node, the other node will contain another student's information, and so on. So the marks is not a single value. There may be more marks, some 3 marks, 4 marks, 5 marks, or something like that, depending on the number of subjects. So the data itself need not be a single value, but then even if the data is a single value, I need another field, I mean there is another field which I need to allocate, I mean give space for, and the other field is the link field. So there are at least two things, two values at least in a node, at least two values. If there's no data, there's nothing, so you need to consider data. And since we're going to store data, that's why we are using a linked list and all. Data, a single value, so we have data and link field, two values and a single entity. How do you implement it? Using structures. Be right back. Yeah, back. So I was talking about how to implement nodes using structures in C programming. Why structure? As I said, there are at least two values I'm going to store in a node. I mean have in a node, not store or have. I think I'm going to have two values in a single node, and yes, a node is a single entity and I need to have two values. The two values need not be the same anyways, since they are both together are considered as a single entity. Structure is the best thing I can use, because a structure is a user-defined data type and I can have more than a single value and consider it as a single single entity, and that's why we use structures. That's an explanation. So what type of structure should I use? Yes, what type? Why do I say type? Since it's not a normal structure, we're going to use a different type of structure here. Actually not different type, a special type of structure. Why? I'll explain it. Before that, you need to know about dynamic memory allocation, as I said before, and you need to know about pointers and how do you access the members of a structure using a pointer. Keep that in mind, and yes, I'll proceed. So what is the special type of structure we're going to use here? It's called a self-referential structure. So yes, why use this special type of structure, and what is a self-referential structure? And I'll tell you more things one by one. I'll tell. So yes, dynamic memory allocation also should be explained. Why should I use it? As I said before, I'm going to allocate memory dynamically while executing the program, and then and there I'll be storing the data information. So I have initially I don't have any node, say I don't have any information, and the user needs to put a single information, a single node. I ask him to input some values, and I'll allocate some memory dynamically, and I'll put that information in it. And then again, if he wants to add another information, another node, I'll ask him to input again some set of values, and again I'll allocate some memory and store those values in that node. The memory allocated is for the node, so I'll store those the values which are being input into that node, and I'll link the two nodes. So how do I link it and other things? In the treasure hunt game, which I told you, the example which I gave you, the chit had some text, and it was denoting to a place, a location, a real-time location, like Alex's room door and Kiran's math book and something and all. So Alex's house is a place, and in that his room is another place, and his door is a part of it and all. So you have a name for place in real time. In virtual world, in the computer world, if you are storing information, we store information in memory, and if you want to denote a place in the memory, we use memory addresses. Yes, to denote a location in the memory, we use memory addresses to denote an information where information is stored and all. So we're going to play with memory addresses, hence we're going to use pointers to play. and that's why we use pointers. So what is a self-referential structure? It is a structure which has two fields, one data field and another link field, and this structure is the node, this self-referential structure. I'll have the name of the self-referential structure as node. So the data field, I'll have a single data this time, and be right back. Sorry. I have a single data in the data part, some integer I, and as I said, the link field. This link field, it has the address to the next node. In the treasure hunt game, as I said, it has the name of the location where the next clue is there present. Same way here, it's the memory address of the next node, actually speaking just the starting address. If you know pointers, I'm sure you must be knowing about this starting address and all. If you know pointer pointing to arrays and other things. So yes, the starting address. So to denote this memory address, to to point or to store this memory address, we're going to use a pointer. Since each node is this structure node, I mean this node, each node is the structure itself. To point to this structure, we need to have a pointer of the type of the data type struct node star. Maybe I'll name it as next, since it's going to point to the next node, that is the consecutive node. Point to the next node in the sense have the address, the starting address of the next node, so that there's a link between this node and the next node. And more in the next video. That's all for now, and I'll explain more about this also, why it should be a struct node. Though I did some explaining, I'll tell it more about it.